let's take a look at question 1. Well, the question, as you see, is formatted as a data sufficiency question. Yeah, I will not write the options because you know better. And the question goes like this. Notice some common characteristic to any coordinate geometry question in the GMAT. They begin with a formula such as in the XY plane, in the rectangular coordinate system, etc. Okay? Always like that. So the question goes, is the slope of some line L positive? And you have these two statements. So what's the answer, do you think? Remember, the slope of line L positive. Imagine you have a line L such that, the equation of the line is like y equals m times x plus b, right? M the slope, b the y-intercept. And so they're asking you whether the slope is positive. That means that the question is this: is m greater than 0? That's the actual question, right? So what do you think? This is not rocket science, so we'll just leave stand by for a minute, okay? Think about it. First says the x-intercept of L is positive. Second says the y-intercept of L is positive. What does that mean in each case? Let's go over this together. The first one is sufficient? Yes or no? It's not much to think. It's either sufficient or insufficient. What are your arguments, people? Can you visualize for a moment a line having an x-intercept with a positive sign? People, what does the x-intercept mean?
It's not enough.
Not enough. Why? Why?
Because you just have one intercept. It could be any angle. If you take the first one or the second one, it's not enough. You've got to use both.
Yeah, people, thank you, Lorena. The x-intercept is, the position where the line crosses the x-axis. If the x-intercept is positive, they are essentially telling you something like this. The line crosses the x-axis over a point in this position, the right hand, side of the horizontal axis. It doesn't cross over here. It crosses only in this position. But does that tell you the orientation of the line? So, for example, you could have this line or you could have this line. Clearly, the information of the sign of the x-intercept alone doesn't tell you the slope of the line, let alone the sign of the slope. You don't know. This could be, for example, here is a negative slope or a positive one, and here you would have a negative slope. Both lines crossing with an x-intercept of positive sign. So clearly this is not sufficient. You can't answer the question. You have two possible answers, so not sufficient. Second statement, the y-intercept of L is positive. So this is a similar analysis. Now they're telling you that this line crosses the y-axis over here, in any part of the positive half of that axis, that is above the origin. Here's the origin. But having a line crossing in that position, does that tell you the orientation of the line? Clearly it doesn't. You could have infinite lines, each of a different orientation, so you can't tell whether the slope is positive or negative. Not sufficient either. And now you are compelled to analyze the two statements together, the two conditions being true at the same time. So notice what will happen. The first tells you that the line crosses in any point in this part of the x-axis, let's say something like this, and the second one is telling you that the line crosses in this half of the vertical axis, let's say a point like this. But if you just pick a point in the upper half of the vertical axis and the rightmost half of the horizontal axis, you will have a slope or a line with what kind of orientation? It will always be declining or descending from left to right. That's equivalent to a negative slope. It couldn't be otherwise. Yeah, you can change, right? The position of both intercepts. Let's try that. For example, what about this? Or what about this? It doesn't matter how you move the points. The orientation will always be descending from left to right. So this is a unique answer. The answer to the question is a no. If you take the two statements together, the orientation of the line is not positive, but negative. But it's a unique answer, so sufficient. Correct answer, option C. An interesting variation of data sufficiency, coordinate geometry, is considered a blend of geometry and visualization, right? And probably that's why, they kept this question format in the GMAT. Yeah, you have to be very analytical to nail the correct choice.